I can't see the stream yet. Oh, I can see it now.
All right. I'm not sure if this is live. We should be live. Are we live?
I think we are live. I can see myself, I think.
Can anybody
Which is
confirm we're live? We don't know how to use this stuff. Do you know how to use this stuff, Mishra?
I don't actually. We're good with podcasts, but
We're good with podcasts, just can't manage
can't manage video.
anything else. Well, I think we're live. And that's exciting. I'm excited. How you doing, Mishra? Good
I'm
buddy?
super excited. I'm really, really excited for this.
Well, we are live. Hey, I'm telling you, it's just as well we weren't saying anything like throwing shade or anything like that on anybody.
No, not yet, not yet. I think that stuff will come as we go through with this.
So I want to introduce my good friend Anubhav Mishra, who's with me today. And we're going to be talking about a brand new thing, which is a feature of Kubernetes and, integration for Kubernetes from HashiCorp Vault, which was just released just yesterday. And I'm really excited about it. The ability to kind of easily integrate Vault secrets into Kubernetes. Super, super cool. So thanks very much for joining us, Mishra. It's always amazing to be able to hang out with you.
Nick, you don't have to do that introduction, but I appreciate it. And yeah, I think knowing Nick over the years, it's been always exciting whenever we get to do content together. So it'll be a lot of fun. We'll go through some of the areas that I feel will be interesting to users using Kubernetes and using Vault alongside for secrets management. So I think this will be a fun one.
Nice. Now, I think before we kind of kick things off and start looking at Kubernetes, there's possibly a few people who are maybe not so not so familiar with Vault and kind of the purposes of Vault and how it works. So I was wondering, would you be able to give us a quick Vault 101, Mishra?
Yeah, for sure. Yeah. So I'll keep it less not state the official definition of Vault and just go with kind of a plain and simple definition. So Vault is a secrets management tool. It allows you to manage secrets centrally, and it makes them available using API. And you can use the CLI tool that is basically a single binary that you can run. Which runs the servers, it runs the agents, also runs the CLI component of it, also has a CLI functionality. And then Vault has things like authentication methods, so that allow you to kind of authenticate with Vault. So you can treat Vault as a web application. So you need a username and password to get a session or a cookie, like in a web application. Vault's very similar like that. You need some form of identity to authenticate. And you can use, your GitHub credentials. You can use LDAP. Use whatever you're using in an organization. There's various authentication methods. So once you get a token,
So I'm not bound to using a single authentication method. I can use lots of different things, as you said, GitHub or LDAP, all at once. Can I use a combination?
I think you can use a combination in an organization. Maybe certain teams are more bound to LDAP, and certain teams are more used to GitHub as their workflow. So you can always map those authentication methods with certain types of policies involved and restrict access that way. So yeah, that's kind of the authentication side. And And there's then this secret engine that allows you to kind of, encrypt things or store things. So you can store simple key value stuff into Vault, just use Vault as an encrypted memcache. And then you can do things like encryption as a service. You can do more interesting things like, storing, generating database credentials, cloud credentials dynamically,
Nice.
and revoke them if you want.
That sounds pretty neat. And we'll look at a couple of those today, but I really love the way that the sort of the dynamic database credentials, how you can generate those. I think that's really cool. And I'm excited to show folks how to do that in a little bit.
Yeah, I think you have a bunch of demos lined up around that. So I think it'll be a lot of fun going through them.
Yeah, I mean, like everybody says, pray to the demo gods. I've came to terms with the fact that the demo god hates me. There's no point praying to the demo god to try and appease them. They hate me anyway. So if people are here to see a demo go bent, like there's a high chance of that happening. So we'll see.
This is all live, yeah.
We'll see what goes on. Alrighty, so let's dig in. Let's get away from this slideware and let's get straight into some codeware. So what I want to kind of look at is getting started with Vault. So I'm not going to run through like how you sort of install Vault and things like that, because we've got other resources to do that. We've only got a certain amount of time. So I really want to kind of concentrate on just getting through and showing off these features. So we're going to make certain assumptions. We're going to make assumptions that people have a Kubernetes cluster and they understand how to use it, and they understand how to use Helm to be able to install Vault. So what I'm going to do is I'm going to use a tool called Shipyard, and Shipyard lets me create Kubernetes clusters in Docker on my dev machine, and it'll install Vault for me, which is like super easy because I can spin these things up and tear them down straight away. So I don't have one of those, so let me create that cluster. So yard up.
Nick, if someone were to download this Shipyard tool, what's the kind of the location? Is there a URL they can go to?
Yeah. Let me, while we're waiting for this to spin up, I will show you that right now. So Shipyard is at shipyard. If you go to shipyard.demo.js,
Sweet. That's a great
you can install
domain name.
Yeah, it's all Bash. This is like as low tech as low tech can get, but it works pretty good. The concept is, as I said, I want to throw away dev cluster because I want to play around with all of this configuration, and I just want to be able to throw the cluster in the bin and not have to wait eons for it to spin up. We've also got an environment which is running in Instruct here, and in Instruct you can actually get a Vault Kubernetes environment in a web browser. We'll share these links in a little bit, but you can find that at instruct.com/HashiCorp. Now then, what we're doing, so Shipyard's just going to install Kubernetes on Docker for me, and it's then going to run the Helm chart. So I'm using Helm to run Vault on Kubernetes. You don't have to use Helm to run Vault with Kubernetes. You could have an external Vault cluster and you can kind of link into it, but I quite like running Helm. It's nice and easy. So if I run just kubectl get pods there, you can see that I've got a couple of pods running. So what I've got running is the Vault server. So I'm just running Vault in dev mode from my Helm chart. And I have the agent injector. So the agent injector runs as a mutating webhook. It's an admission controller. So whenever I submit a deployment to my Kubernetes cluster, the Vault injector there is going to modify it to be able to add all of the authentication mechanisms and the secret injection that we'll see. So it's pretty neat. Vault, I've just got Vault running there, so I can do Vault status, and we can see that Vault's just running up there.
So we're just using a dev cluster, I'm assuming?
Yeah, just Docker. Look at that. There we go. Rancher K3S. Big shout out to Rancher. Cool. I think this is a really, really wonderful tool.
Yeah, I love K3S.
Yeah, and just Shipyard. Nice. All the bash. So what I kind of want to run through first with people again is starting to look at static secrets. So how do we inject static secrets into our pods? Can you give me like a quick 101? What is a static secret in Vault? How does it work? What's the background behind this stuff?
Yeah, so I think a good, like I'll kind of define this using an example. So I think a good example of a static secret would be, let's say your company's Wi-Fi password or something, like internal Wi-Fi password, or an API key for SendGrid, services, third-party services like that, which don't quite change. You generate them once, maybe you rotate them once a year or something, but they don't quite change. So I think those are kind of some of the static secrets. And with Vault, I think you can use just a simple key value store to just encrypted key value store, just store that key in and get that. And everything is encrypted at rest, and it's stored using the encryption as well, and it's stored encrypted as well, and then you can retrieve it using an API or the CLI.
Nice. Let me quickly show the good folks that in action. So I'm just going to use the Vault CLI. I could be using the Vault UI, which I've got running here. Or I could be using the API. So if you're using your sort of your infrastructure as code, you can obviously use API. You've got Terraform providers and things like that. If you're familiar and comfortable using a UI, then we've got a UI. But all of this demo, I'm going to run through the CLI because that's kind of where I'm at. So if I want to store a secret into Vault, I can just do Vault KV put. And I'm going to do secret. I'm going to call this web, and I'm going to set a secret field of API key, ABC, blah, 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 whatever's. And that writes there. So we can see there that I've written that. So I'm using, oh, sorry, Matt, go on.
I was just going to say you're using like a specific path, right? You're saying secret/web. So is like, how do you, like, can you have like multiple things in the same path and stuff like that?
Yeah. So I could, the convention that I'm using here is like web is my application name, but I could do something like, let's say I've got an application called payments and I want to create something called keys. Then, I can create any form of subpath like that. It's like really flexible. We're not kind of putting any, it basically allows you to model things the way that your sort of data models work. It's pretty neat.
Cool.
And of course we can get those things out because we can do Vault KV get secret/web, and there we go. So we can see the secret that I stored earlier. So I've got a secret now in Vault, and what I want to do is I want to inject this secret into my application configuration on Kubernetes. So to do that, what I need to do is I need to configure my Vault to be able to authenticate with Kubernetes service accounts. So the service account in my deployment can be used to authenticate with Kubernetes to be able to give it the correct permissions to access that secret and then inject it in terms of configuration.
So this is the kind of the login process we talked about, I think earlier, that like Vault requires you to log into Vault and then be able to operate. So I think in this case, I guess we are using like a specific thing in Kubernetes, Nick?
Right. Yeah. So so Vault's got those authentication backends that you were talking about earlier. what we're going to use is we're going to use the Kubernetes one. So the process is that Kubernetes is going to add a service account token to your application. It's going to make it available in the instance we're going to show a deployment. When we run the injector, and the injector is going to add a Vault Auth pod inside of our deployment automatically for us. That's going to use that service account token, and it's going to log into Vault using the service account token. So Vault needs to validate the service account. So Vault has to then talk to the Kubernetes API, validates the service account token, and if everything's correct, it gives you the authority to request secrets. So this is kind of like a one setup kind of that we've got to do when we install a new Vault cluster with our Kubernetes cluster. It's pretty straightforward. It might feel like a little bit of boilerplate, but nah, it's pretty.
It's a one-time thing. One-time thing. You authenticate, you configure it once, and then your applications can use it right away multiple times. You can reuse this authentication method, I guess.
Yeah, let me show you. So the first thing that I need to do is I need to enable the auth method. So in Vault, all auth methods have got to be enabled other than the secrets engine. That's the only one that's enabled by default, that and Cubbyhole. So I'm going to enable it. So once it's enabled, the thing that I've got to do is I need to configure it. So all of this has got to happen before I can start injecting and getting those secrets, but I'm going to configure it. So how am I configuring it here? Well, what I'm doing is I'm cheating a little bit actually. So I'm going to run this command inside of my Vault server pod. I'm just using kubectl exec because all of those service account information that's available in the file system. Of course, I could get this from the Kubernetes secret. It's all in there. But when you install Vault with the Helm chart, Vault is going to define some RBAC rules. And the RBAC rules are going to give the Vault server permission to communicate with the Kubernetes API in order to authenticate service account tokens, just to validate that they're genuine. So what I'm doing here is I'm writing this configuration. So I'm doing Vault write auth config. The token reviewer JWT. So this is the service account token because Vault needs its own Kubernetes service account in order to talk to the Kube API. We need to pass the location of the Kubernetes API server. So because I'm picking this up from a pod, I can just use the environment variable, and I need the CA cert because the API server is using TLS, and Vault needs to validate that the TLS certificate is correct. So those three pieces of information we're just kind of setting up there. And that's as easy easy as that.
That's a one-time thing.
Right. So now we've got that. What can happen is the pod can use the service account to authenticate against Vault via the Kubernetes API. But the thing that we need to look at is you need to determine which secrets can that pod or that deployment or that service account really, which secrets can it access? So what we do is we're going to use Vault's policy. So everything in Vault is a path. So if you remember before, I was doing my secret. I did my Vault my get on my secret
KV-get,
web.
I think.
Yeah, KV-get.
Yeah.
So I'm going to define a policy which allows me read on that secret. So the deployment I'm going to run, which has a service account web, is only going to be able to access that one particular secret inside of Kubernetes. Inside of Vault.
It's only going to be able to read it, I guess.
That's right, yeah. So it can't write any changes. It's literally read.
Right.
And Vault policy allows you to kind of segregate those things, read, write, create, update, delete, all that sort of great stuff. So what I need to do is I need to write that policy to Vault. So let me do that. So I'm going to make sure I'm in the right folder, which I wasn't, and I'm going to write that policy.
Cool. Live demos.
Always. Right. So we've written that policy to Vault, and I'm using the Vault policy right. I can do Vault policy list, and you can see there I've got web static as well. There's a load of great materials on Learn at HashiCorp if you want to learn a little bit more about Vault, but we're going to specifically kind of concentrate just on the bits you need to know about Kube secrets today. So I've added my secret. So what I need to do in addition to a secret is I need to have a role. So what does a role do? So policy defines the secrets which are accessible. The service account allows you to authenticate with the author backend. So what's a role? Well, a role ties those two things together. So if we have a look at that, what a role does is it says that the service account called web in the namespace default has access to the policies web static. So that was the policy which will allow me to read our API key secret just before that. So I've got to make that configuration. So I'm going to run that, and that runs. Okay.
So the role kind of sits on top of the policies, I guess.
It ties the two together. It's a kind of that intermediary between a policy and an authentication.
Right.
It just kind of ties all of that access together.
Right. So I'm assuming that you can have like multiple policies in that role. I guess you can have like a web static and maybe a DB static or something like that.
Yeah, absolutely. You can combine multiple policies up into there. So what we've got now is we've got everything set up so we can actually start injecting the secrets into the pod, which is kind of cool.
Yeah.
Let's have a look at my deployment or my Kubernetes YAML file. So I'm creating a simple service that's not relevant to this particular thing. The things that are relevant, service account. So I need to have a service account for my deployment. So I'm creating a service account called web. And if you remember just previously, I created a role which references web and allows the static secrets. So I create that service account. And then I've got my actual deployment. So my deployment, I'm going to create just 2 replicas, and I'm going to add that service account to there. You can see there. Now, what I'm doing to do in my injection is I'm using these annotations. So this is where the magic happens, I suppose. That all of the secret injection and the configuration of the secret injection is happening through these metadata annotations. So we've got this namespace annotation here, which is vault.hashicorp.com/agent-inject. And we're setting that to true. So that mutating webhook, the injector controller, is going to modify this deployment, and it's going to add all of the authentication and the secrets injection for me. And we'll look at that in a bit when I've run this. But the next is that I'm defining that I want to use some secrets. So I want to use this secret called web, and I want to store that. So I'm gonna store that at Vault Secrets Web. So that's kind of the convention around that. But if I just kind of wrote that just as a plain secret, it's just going to be like a key value pair. That's not necessarily what my application needs. What my application actually needs is a JSON formatted configuration file. So to be able to do that, I can use console template features. So again, I'm using the annotation agent inject template web, and I've got a console template here. So console template, like anything where you see the double curlies, that's a template variable or a template function. So let me just break this down for you. So I've got just a standard JSON opening brace, and then I've got a console template. So I'm saying with secret data web. So that secret that I created before, so the path that's also referenced by my policy, just here.
Yeah, I think it might be useful to show. Yeah, there we go.
What I'm doing is I'm going to say that anything inside of this block. So I want to retrieve that secret from Vault, and I want to use the value. So again, I've got a template variable here. I want to use the value API key from that secret, and I want to store it in a string, which is just part of my JSON configuration. Then I'm just closing that block, not going to use that secret anymore, and I'm closing my configuration file. So console template.
I guess this just makes it very useful. So you can kind of, I guess you can generate like, things like database access strings. I can think about so many different ways of like, generating, getting the secret data out securely, and then, putting it in a way that the application just reads a file. In that case, I guess the application is not aware of Vault being there, I guess, and doing all this for you.
Yeah, and that's the beautiful thing. My application has no knowledge whatsoever that it's getting its secrets from Vault. It just thinks it's reading its usual app config file. And yeah, we can define these. I'm using JSON here as an example, but you could use YAML. If you're writing Java, you could write some XML. Shout out to all the Java programmers. And if
that's a good one.
I troll. I can't help myself. But it's configurable. You could do anything you want. If you just want key values, if you just want a simple single string, anything you want, you can do there. The last annotation is that I want to tell the authentication to use the role web. So that's just going to be part of the authentication process. That the role web, we defined that earlier. That's the one which kind of does that mapping between the service account and all sorts of wonderfulness. Basic pod stuff. Got my service account name, so just pulling that in, and then I've just got a single container exposing a port, and I'm just setting an environment variable, standard stuff for my app, because it needs to know where my config file is. So I should be able to just run that.
So what is this app gonna, like, is this app gonna just read the file and show you something, or?
Yeah, I mean, the app just literally reads the config file in. We'll what I'm going to do is I'm just going to dig into the container and show folks the actual file itself. So kubectl apply -f config web. Let's run that. So it's created my service account, created my deployment, and we can see that's running. So I've got 2 replicas in that deployment there. Okay, cool. So that is all running. So what's happened now?
And I see that there's 2 containers there.
Yeah, that's right. Yeah. So let's have a quick look at the logs. And let's have a look at the logs from the injected Vault agent. Oops, sorry. From the injected Vault agent. And we can see there that this is all happening behind the scenes. So Vault has picked up the service account token, it's authenticated against the Vault server, and it's retrieved the secret. So as I mentioned earlier, all of that injection and all of that management, all of that stuff is happening through the injector. The injector is mutating my deployment. If I just have a look at that deployment, you can see that even though I defined a single container, then there's multiple containers here. So I've got this Vault agent container. This is just sitting away as a sidecar in the background. It's monitoring my connection to Vault. It's managing all of my secrets. My application's got no idea it exists, and it doesn't need to. Whenever any of the secrets change, the Vault agent is automatically going to detect those changes, and it's going to rewrite my config file, Vault secrets web, which is cool. I mean, this was kind of all possible previously, but you had to manage all of this lifecycle yourself. You had to put all of the boilerplate in yourself, generate all of your own console template. Like, it's just a million miles ahead now with the simple annotations. It just makes the workflow so much nicer. Let's look inside.
What about like, for example, Nick, if the token that we got from Vault that allows the Vault agent to grab the secrets, what if that token expires? Like, because I saw you configure like a TTL to the authentication methods. Like, how does that automatically renew using the agent, or do you have to specify something?
Right. Yes, I didn't mention that. So I did configure this TTL. So what I configured was a time to live. So a Vault token has a time to live, and this is kind of a standard Vault mechanism. So you're absolutely right. If you don't use a token, then it will expire. So if there's another part of the process that you would have to manage yourself, you've got to kind of keep the token alive. You've got to keep saying, I'm still using these secrets. Please don't remove my access. The Vault agent will absolutely do that for me. So it will make sure that the connection to the Vault server is kept alive. So I'm in my
That's awesome.
my pod now. Well,
you were in your pod.
I'm pretty sure I'm in my pod. I think my terminal's frozen. Let's see if we can get another one.
There we go.
Oh, I've just changed a new one. kubectl exec it.
I remember, like, back when you would exec into few containers, they would give you a warning saying that, hey, like, hit a return to make sure that, like, to go to the next line to exec again. So it was like an extra return that you had to do with execing into containers. I wonder if that's changed. Oh no, there we go.
No, there we go. So we're just in the file system of the container there. So all of those secrets are written to Vault secrets. So if I go cd Vault secrets, what you see there is I've just got a text file. So that's the configuration that I wrote with my deployment here. So that JSON file. So if I have a look at that file, you can see that I've got that JSON formatted file, and it's got that API key secret, which I created in Vault. It's been automatically injected into my pod, which is pretty cool. Like, the amount of setup, we had to do a little bit around getting the roles, getting the authentication, and all that sort of stuff done, but that's all done. So we can kind of move on now, which I think is cool. But I think we've got something even cooler, because the thing that I'm really excited, which I really, really love, is dynamic secrets. And
cool.
Like, you alluded to kind of what a dynamic secret is before, but we can actually generate database credentials with Vault can generate database credentials for us and automatically inject them into our applications, which we're going to look at that next. Can you explain that process to me a bit, Mishra, mate?
Yeah, so I think the way dynamic secrets work is this is kind of a new thing for a lot of folks. So Vault actually handles the life cycle of a secret in this case. So for example, in the Postgres example that you see on your screen, Vault will, you configure Vault so it can access the Postgres database. Vault will have an elevated privilege. So it'll give Vault like not the root password, but you can kind of give it an elevated privilege,
right?
That allows it to kind of maybe create users only. So what Vault would do is actually, once you request a database credentials from Vault, the Vault will actually make a call to the Postgres database, create a user for you dynamically, and send it back to you. And also set a certain amount of, a certain TTL, which Nick alluded to earlier. And then what will happen is, over time, the application can keep telling Vault that, hey, we are still using this database credential. And if they don't, then it will automatically be revoked after it expires. So some operation, for example, might only need the database once. So you can have a really low TTL. They can use the credential to maybe write something to the database, and then the credentials will expire automatically. And you can actually see this end to end while revoking the secrets on Postgres. Yeah.
So what you're saying to me is that I can't just put a post-it note on the corner of my monitor with the root credentials for the production database?
Well, there are better ways now. This is 2019 still. We can do a little bit more advanced stuff now. So you don't need the whole post-it or writing it on the whiteboard in company in a brainstorming rooms and meeting rooms and stuff like that. You don't need that anymore.
Let me just check. Yeah, I'm pretty safe. My root creds. Let's have a look at how that works, because I think it's pretty cool. Let me quit out of this. So the kind of the process for a lot of this stuff is is the same. We're kind of not really doing that much differently. It's kind of repeating the same workflow,
right?
So, which is nice, because there's there's a pattern which you learn really quickly. So what we're going to do? So we need to enable a database backend, and we need to configure it. So I'm going to do that. If you remember when I did the enabling the Kubernetes auth, I used this very similar command, but I'm using Vault Secrets enable database this time. So that's
these are kind of the secret engines that I talked about earlier, right. I think, and then
So we kind of we enable that, but I do need a database. So let me just run a database on Kubernetes. You don't have to be running your database on Kubernetes. You could be using managed cloud databases. You could be using bare metal. Vault just needs to be able to contact it. It could be running anywhere you want. I'm just running it on Kubernetes for convenience.
I was just going to say, is it a good idea to run a database on Kubernetes? There's such a heated debate about this, right? We all often see that online, that people are always questioning whether it's a good idea or not. I think, the opinion is that, I guess, I would use as many managed services as possible, as it takes away from the operations overhead.
I'm a big fan of managed services because I don't need to worry about stuff. Somebody else's problem from making sure that the actual service is up and server. I can just concentrate on the application logic. So yeah, I mean, however you want to do it, I think it depends. I mean, some people need to run their own databases on bare metal because they need performance, and maybe some people kind of, if you want to run stuff in like a dev test pre-prod type thing and you want to kind of do things cheaper, you can maybe run it on Kube. I'm not gonna say anybody's right or wrong for doing that. Right, so let's have a look.
Stay away from that debate.
So yeah, I'm staying away. I'm avoiding that one. So we've got Postgres running now. So what I'm going to do is I'm now going to configure Vault. So I'm going to configure that database connection. So what am I doing here? I'm using another Vault configuration file. I'm specifying a plugin. So I've got a Postgres database. So I'm using the Postgres database plugin. Vault supports MySQL, Cassandra, Redis, a bunch of different stuff, all in the kind of the documentation. I'm specifying which roles are allowed to use this. So I'm just going to say everything at the moment. If you remember, the role is the thing that kind of ties a secret to a policy. And we're technically setting up a secret here, just in a very different way. And then I've got the connection URL. So this is just a Postgres URL. I've got the username and the password, and I'm using template variables. See that you've got those double brackets there. And then I've just got Postgres 5432 because I've got a service running in Kubernetes called Postgres. The server's at 5432. My database is called Wizard, and I'm disabling SSL mode. So I am hard coding into this configuration the username and password, which is, I mean, it doesn't get much more secure than this, but I'm using Postgres and password. But the thing is, I've got a little trick to show you that means that that doesn't really matter too much. So let me write that configuration. That's going to allow Vault to be able to connect to my database, to be able to generate credentials on my behalf. So there we go. That's written there. So let's just kind of log into the database and make sure that it is working. So kubectl exec. I think it'll be.
Is this step that you just did, the configuration step, that's also a one-time thing, I'm assuming?
It's a one-time thing for each database, yeah. Yeah, for every database you've got to do that that one-time approach. So I'm just on the database here. So I'm just going to use psql -u postgres. It's going to ask me for my user password because I do everything super secure, and
Super secure.
that's all worked there. So let me quit out of that. So the thing is, I now know the root credentials for the database, and I don't need them. So I've got that tendency. I'm going to write them on a piece of paper. I'm going to stick them on the side of my monitor. But the Vault's going to generate all my credentials for me, so it doesn't need it doesn't need anything at all. So what I can do is I can use a feature which allows me to Vault automatically rotate my root credentials. So I'm going to run this command, vault write database rotate root for the connection wizard. And what that's going to do is that's going to change for me the Postgres password, and it's only going to store it in its encrypted state in Vault. It's not going to give it back to me because I don't need it anymore, because everything Vault, it can now manage those credentials. So if I run that, and again, let me just bounce into Postgres, and I'm going to do psql -u postgres password. Well, the only password I know was password, and you can see it's not working.
I was just going to say, did you misspell password?
No, I definitely typed password correctly. I mean, I've been using password as my main password for the last 35 years, so I got that one down.
Oh my God. Nick, this is live. You don't want to put out these secrets out to the world.
Oh yeah, I'll be good. So we're nearly there. So what do we need to do? We need a role. So I need to create that database role. I created the connection, whereas a role, what that does is that's going to generate credentials of a particular kind. This is really nice because I can specify that Vault generates me credentials for particular access levels. So here I'm basically just creating admin credentials, and I'm doing it just using pSQL. And this is a kind of a feature of all of the database connections in Vault. So I'm just using create role. The name of the role is going to be whatever the random username is. And then with login password, random password, because I'm using these template variables, which is going to be valid for a set period of time. And then I'm just granting select on all of the tables. So I'm creating some credentials in my Postgres database, which will allow me to select on anything in the schema.
So the creation statement there, Nick, can that be any arbitrary like SQL, right? Like, does it have to be a specific? Okay, that makes sense.
Yeah, it could be literally anything at all. Any valid Postgres SQL will work in there. And the nice thing is that what you can do is you can create different roles. So here I've got a DB app role because my application only needs to read from the database. So I create a DB app role. But I could create an admin role for myself, which allows me administrative access to the database, and I can do that just by creating a new role. So I create the DB app role there. Maybe I create a role called Nick, and it creates grant. I've got no idea what the not that. I've got no idea what the kind of the P-SQL is for granting all, but something like that. But the DB app role is the thing I care about the most.
Sounds good.
So I've got that DB app role. Let's have a quick look to see that Vault can generate those credentials. So I can manually.
So, Nick, again, to be clear, like Vault will be executing those create statements on your behalf, I guess.
Yeah, it works literally just like this. So I request to Vault for it to create me some credentials. Vault talks to the database, and it will generate a brand new user account and password pair in the database, and then it just gives them back to me. And it manages the life cycle of those. So after a set period of time, it's automatically going to go back to the database and it's going to revoke them.
Sounds good.
And I can do that. So I'm just running the Vault read command. There you go. So there's the database credentials, the username and password for my wizard database, which is great. But how do I get that into Kubernetes? So let's look at the last couple of steps. So again, we need policy. So policy is a thing which allows me to control the access to secrets. So I created policy before, which was allowing me a static secret. This time I'm creating access for database, creds, DB app, read. So I'm only allowing the thing with this policy to generate sets of credentials for that. Can't do any configuration, can't read any other secrets, can only generate credentials from the DB app role. And I need to write those into Vault. So I can write that policy exactly the same way, Vault policy write. And then what I need to do is I need to create that role. So remember, the role is the kind of the thing that ties the login to the policy. So exactly the same way that I did for the standard secrets, I'm doing Vault write, auth Kubernetes role, web. Anything that's authenticating with the service account web in the namespace default is allowed the policy web dynamic. And the web dynamic allows you the capability of creating database credentials from the DB app role. Let's run that.
Cool.
So now we can just inject those into our app. So what does our app configuration look like? It looks very similar to
yeah, I was going to say,
to what you would have seen earlier. So the app itself is exactly the same. This is just the same deployment file. The only modification that I've made to it is down here in the annotations. The annotations are actually even the same. They've just got different names there. This time I want to use database creds DB app rather than secrets data web. And my injection template, even though it's slightly different because I'm generating this DB connection, the concept is exactly the same. I'm telling Vault that I want to use, I'm telling the template that I want to use a secret, and then I'm just using these variables, which are the secret values, username and password, and I'm just going to substitute those inside of the DB connection. Got the service account there and just my configuration file. So literally nothing is different. So we should be able to run that. So kube ctl -f config web. Apply.
I was just going to point that out. You also, I just noticed that you're in the kubectl clan. You're not kubectl or.
No, I pronounce things correctly. Yeah.
I was just gonna point out that is a point of contention for a lot of people. Right?
No,
okay.
That's a hill I'll die on. This is definitely kubectl. So, but you can see there that we've just kind of run that. It's terminating the old deployment. It's adding the new one. Exactly the same thing. So let's take a look at that that web deployment. And you can see that even though I've got that single container, because I'm using the injector, the new Kubernetes integration, it's automatically adding the Vault agent. Vault agent is automatically going to do all of the authentication to Vault. It's going to deal with the kind of the secrets management for me, and it's going to maintain the life cycle of those secrets automatically for me, and it's going to rewrite everything as and when I need it. The cool thing, though, I think, is that we can have a look at those secrets in that pod. So let me just bounce into my web pod.
I'm excited.
Yeah, I hope this works, because if it doesn't, it's all 100% a Jackson related error as opposed to anything else. But there we go. Well, we're in the mount path, which the injector's adding for us. We got a file there called dbcreds, which is the one I saved. If I cat that, there we go. There's my database connection string. You can see
that's a long username.
That's a long username, but you don't care because it's automatically generated. It's just the machine needs to use it. And the nice thing is that these usernames, this is auditable. So any trace of an action on that database can be audited back to this specific pod, which is kind of cool. We've got the password there. Again, it's all randomly generated. I've got two deployments running. So let me just have a look. Sorry, two pods in that deployment. So let me look at the second one. And again, let me do the same thing. So I'm just going to do cat vault secrets dbcreds, and you can see that I've got a completely different username and a completely different password, and that's because Vault is injecting unique database credentials into every instance of my pod, which is kind of cool, considering like all I had to do after a little bit of setup, but it's a fairly sort of trivial annotation for the benefits of having automatic sort of injection stuff there. Lachlan is getting missing client token command terminated with exit code 2. Have you got a service account on your pod? Maybe it could be that.
Oh yeah, there you go. We can come back to the questions.
But we can come back. But we're done. That's it. That's kind of the thing that I wanted to show you. I'm really excited about this. I think it's a great tool. Yeah. If folks want to know a little bit more about sort of all of these things, then we will put some links in the YouTube comments there. And the demo code, again, like all of the stuff that I've gone through today, I've got a repo here which has got the demo code. You can check out the documentation on vaultproject.io, which shows you and runs through the process of installing Vault with our Helm chart. You can also see some more details about the agent injector, some more detail on actually how it works, and some more sort of examples on the annotations, because we only covered just a sort of a few of those things today. What else have we got? Yeah. Well, if you want to try it out, there is the instruct environment, which is running here, and you can try that. That'll just literally start everything up in a web browser for you. And there's a blog, which I think is a pretty good blog. Guy called Nick Jackson wrote it. Don't know who he is, but
oh my God,
I hear he's dope. I hear he's good.
Okay. Nick, maybe we should read up some of these. One of the questions I think Gabriel asked, and I answered it. I think if the Vault service is not available in the deployment will fail. I think Jason answered it as well. By the way, Jason O'Donnell worked on most of these features that you are seeing in this live stream. Really,
Misha, like, don't do
yeah.
that. Like, we do these live streams for the sole purpose of taking credit for other people's work. Don't go
No.
don't go credit to Jason for who actually wrote all of this stuff just because he's lurking in the live stream. But yeah, big props to Jason. He did actually write all of the code with the team here.
Cool. Yeah. So he asked something about like the deployment failing if Vault's not available. I think usually what would happen is as Jason pointed out, you can also tune the client to have a timeout on the agent container. But in terms of the Kubernetes flow, like the first thing that comes online is that init container. So you will see you'll see if you're using the init container annotations, you'll see the pod just be basically stuck in the init container. And it might fail, but you can totally set a timeout as Jason pointed out there.
Yeah, I mean, I suppose you could make an argument that actually if your application needs secrets to function, even if it comes online, it wouldn't actually work correctly because if it can't get the secrets. But I do want to add as well that Vault is not a new tool. It's something that's been used in production environments of some pretty large, small, and everything in between organizations for a number of years. It's pretty solid and very, very trustworthy. So it's something I hope that you would never ever have to cover. But we can actually see that in action because I can just do kubectl delete Vault.
That's a good test.
But you will see it stuck in the init flow because it's not going to be able to generate the necessary credentials.
Right. You might have to redeploy one of these, I guess.
Yeah, let me just...
You can just kill one of them, I guess. Yeah, so I think that's ideally what should happen, right? Like if the pod comes online, it shouldn't be like basically that deployment should fail because it doesn't have the valid credentials, and you should be pointing out that problem.
Yeah, but if you're at that situation, you've potentially got sort of bigger issues than the pod not starting because it's if your pod can't get the secrets it needs, it's not going to be able to run even if it does start. But Vault's a great tool. I don't think that. I hope that'll never happen for you all. Well,
all right, let's see.
There you go. It's stuck in
Cool.
init phase.
Stuck in init. Yeah, that's what I assumed. And I think Lucky asked, Lucky, our good friend, asked, I think pointed out a problem with the blog, and I think Jason is able to fix it. That's awesome. Cool. So we've confirmed that init container pending. That's a good thing.
Yeah. I'm just trying to think. Does
else,
anybody? Nick? Yeah. I don't. I just want people to. I hope you like the feature and have a play. And of course, we're always available on Twitter and various other things. Discuss.hashicorp.com. Big shout out to Discuss. If you've got any questions about the features, please post up here. A lot of the HashiCorp engineers are following this forum. Certainly we follow this forum. We can get you any answers on there, but yeah, feel free to reach out to us on Twitter as well if there's anything that we can do to help. And with that, we can let everybody get back to their days, I think. Yeah. I hope I've enjoyed this. I've been looking forward to this for a long time.
For sure. I'm really excited to see what the community has to say. I know the Vault team is really excited to see how this is perceived, and us kind of taking another step into the first class integrations with Kubernetes. You'll keep, this is not the end, by the way. Like there's going to be more features that you'll see in the coming year, and I guess it's the holiday time now. So happy holidays to everyone.
Happy holidays indeed, and to you, my good buddy.
All right.
And to everybody. Thanks very much, and we'll look forward to Well, hopefully see you again in the new year. Maybe we got some other new stuff we can show off.
Sure.
For now, laters.
Thanks for tuning in.